All right, welcome to the scalability panel that we're going to be talking about here. I know they were a little bit behind, so I am going to ask everyone here to introduce themselves real quick. We're talking about scalability. We have some of the best in the business up here. So everyone knows that, but let's keep it to like 30-second introductions, and then we'll get to the meat, because that's the important part. I'm going to start down here with Nema.
Okay, well, my name's Nema Jahan from the Unification Foundation, and we are building out a native blockchain with a focus on DID and identity, and we're really focusing on scalability, not necessarily by focusing on more TPS and more nodes, but through governance, essentially, is our main play.
Cool. I'm Marie Leaf. I head up product at Kadena. We are an end-to-end blockchain stack with a private chain and launching a public network Q2 of next year with a smart contracting layer that interoperates the two of them. We focus on scalability on both protocols as well as security, especially on the smart contracting layer.
And I'm Josh Fraser. I'm one of the co-founders of Origin Protocol. We're building the decentralized marketplaces on the blockchain. So people have been talking for a long time about how blockchain has the ability to disintermediate these multi-billion-dollar companies like Uber and Airbnb. And so we're actually working on that problem and enabling any number of different types of digital marketplaces on the blockchain. We're building on top of Ethereum, and so we can talk about the scaling initiatives on that front.
I'm Charles Hoskinson. I build stuff.
All right, awesome. Best introductions of the entire weekday. All right, so let's get it started. We're talking again scalability, obviously. I'm going to hit you with a really open-ended question, Nema. What do you think is the most important sector to achieve scalability going forward?
Well, when we talk about scalability, there's really two distinct things that people talk about. One is, the magic number of transactions per second. So, during 2018, we had a lot of things coming out. They're saying, oh, I have this many transactions per second, and then somebody else says, I have this many transactions per second. But once you actually get to a productive work environment, into reality, that may mean a lot of things. So we think really the end answer is not going in, quantum computing will get here at some point, but the end answer comes to governance. And governance means you don't need necessarily, in my opinion, to have everybody verifying everything, but more moving towards either a proof-of-stake system or a delegated proof-of-stake system, of which numerous entities are doing a lot of things. So for example, instead of requiring open-ended verification, you have full 100% off-chain governance with checks and balances, which allows things to scale properly.
Oh, so you're saying off-chain governance?
I'm sorry, I meant on-chain.
Oh, sorry, okay.
That's a total slip there, okay. Well, maybe that's part of the indicative, is people get mixed up what exactly is off-chain and what is on-chain.
Mm-hmm. Charles, I know IOHK is working on some different governance models. How do you think that they could apply to help, if you believe that that's a great piece of the scalability puzzle?
I think governance is orthogonal to the scalability discussion. It's not directly related, but you could make the argument that it is. In our view, you have right now, we're living in an ecosystem of replicated systems. So effectively, no matter how many people come to show up, you have the same pool of resources available to everyone. So it's almost like you have a table with a bunch of food on it, and you keep adding chairs around it. You all get less food. That's where we live right now. So what scalability is all about is saying, can we have a situation where people bring food to the feast? So you eat what you kill. In other words, you look at protocols that are scalable, things like BitTorrent, for example. That's a protocol where when more people participate, the faster the thing gets. When you download Game of Thrones, you get it really quickly, because a lot of people are sharing that. Pee-wee's Playhouse, not so much. So that's where we basically need to get, is we need to move from replicated to distributed systems, and there's a lot of ways to do that, and it really stems down to who do you trust? Do you want to have homogeneous or heterogeneous networks? In other words, the network's always going to be the same and everybody has the same privileges, or are there some people who are more special than others, so like master nodes or something like that? And do you want to sacrifice your privacy, and do you want to increase your trust assumptions about how things work? So you can achieve scale, but there's always a trade-off with it. And what we're trying to do as an industry is decide what trade-offs are reasonable so we can keep the original principles of Bitcoin and also make the systems faster as people join them.
Trade-offs is one of the words that I love, and I love trade-off profile, which is a phrase that I've heard you use a lot of different locations. So when you're looking at different trade-off profiles, what is the one that you kind of have to make the sacrifice now that you're hoping you won't have to make the sacrifice in 10 years?
So when we design protocols, we can look at each generation. So the first generation of consensus protocols came out of the study of distributed systems theory. So these are things like Paxos and all these cool things that were done in the 1980s with Byzantine fault-tolerant protocols. And what we've seen in the space is kind of a reimagining of those protocols. So people have dressed them up and put voting systems on top of them, but basically they're materially the same as what happened in the 1980s. So what you have is some special group of actors, and usually it's less than 100, because there's a lot of communication coordination overhead. It's quadratic time. And then some group of people vote to decide who's in that pool. And if you do that, you get lots of speed, thousands and thousands and thousands of transactions per second. But you have a small federated network around a usually unchanging group of actors, and that's well understood who's there. When you do research, what you can do is move your trade-off profile and say, can I get something that has the performance like that, but maybe it's more decentralized. Instead of 20 or 50 or 100, maybe it's 1,000. Or maybe it's dynamic and people come and go, and we can actually shard this, and each of these committees does different work. So that's what a trade-off profile is about, is saying for a particular generation of technology, you get something and you give something up. And if you do good research, you give up less and you get to keep the things that you gave, you are doing, the things that are beneficial to the system. So that's what we do at IOHK. We've written over 40 papers in the last 2 years, 20 of which have gone through peer review at major academic conferences, where we've been fundamentally looking at different ideas, whether they be proof of work ideas or proof of stake ideas or Byzantine agreement protocols. And we've been trying to say, can we make these more decentralized or trust less actors or get all the good stuff that we had with proof of work, but not have to spend the energy, for example, or not have to give up control, for example.
So sticking with trade-offs, Josh, when we're talking about your protocol and what you're doing with, you're trying to achieve, you've thrown out Airbnb, you've thrown out different shared economies, and what trade-offs do you have to make on your end to make sure you can scale to compete with a classic business like that?
Sure. The first thing we think about, and everyone asks us, how is this going to scale? Obviously, Ethereum's not ready for the kind of transaction volume that Uber or Airbnb has today. It just doesn't. At the same time, we look at the volume of transactions on the Ethereum network, and other than a few days, a couple hot ICOs, a few days of CryptoKitties, we're not saturating the throughput we have available. We are mining empty blocks all the time. And so one of the first things we need to think about is, how do we get something, how do we, some of the problems we're trying to address first are how do we just prove the demand and the value for what we're creating before we worry about how to scale. And so we launched on mainnet this year, just a few weeks ago. And what I told my team earlier this year, I said, we're going to be on mainnet before Christmas. It's okay if it's slow. It's okay if it's expensive, but it's got to work. We have to have something we can actually start playing with and experimenting with and learning from. Now, getting from where we are today to where we want to be, obviously we need to scale. We're thinking a lot about ways that we can, what needs to be on chain, what can we move off chain, and making sure that the stuff that we're putting on chain really needs to be there. When you're using Ethereum, you're using the slowest, most expensive computer in the world. So when you're using it, you better have a really good reason. And for us, that's about the chance to cut out the middleman and cut out the fees. So if Uber or Airbnb are taking 30 or 40% out of a transaction, the gas fees you're paying aren't that big a deal. If you can remove that single point of failure in the censorship, then that's worth it as well.
So you said something interesting that I feel like I can take this to Marie. You said the slowest computer in the world. From the Kadena white paper, there was actually a quote, and I realize you didn't write the white paper, but this quote was, "We strongly disagree with the usage of bytecode-based interpreters like the Ethereum virtual machine." So is the fact that it's kind of a slow machine part of that reason? Or what are the reasons behind the Ethereum virtual machine having a...
Yeah, so there's a lot of reasons behind it, but the slow aspect of it for chain web is we actually see the latency and slowness for confirming transactions, and we use proof of work on our main chain consensus. That's kind of a feature, not a bug. When we talk about the EVM, I'm not sure exactly where it is in the paper, so I don't know the context of it, but we want to look at useful operations per second rather than transactions per second. So I think there's the whole scalability conversation kind of got bloated, and we lost the plot in getting, 10K, 20K TPS because MasterCard, Visa is doing 60K TPS, right? That is super reductionist and taking things out of context. For our PAC smart contracting language, we have made it Turing incomplete and baked everything that you need to do for interacting with a blockchain into the smart contract. So the operations per second is effectively a lot higher because you don't have to compile down to the EVM every single time. It's interpreted and it's faster that way. So I just wanted to be clear that the chain web as a whole on the consensus layer does increase the throughput for transactions per second on the consensus layer, but the smart contracting layer is sort of sped up.
Okay, that makes sense. Let me ask you another question. If you had to pick, just like the same open-ended question that I'd asked Nema earlier, what is one of the most important key little pieces of scalability, and how maybe have you solved it on the end of Kadena or on your way to do so?
Yeah, so the most important thing of scalability, I think people aren't focusing on differentiating the use cases. So when you look at cross-border payments, the scalability of Bitcoin and how it scales cross-border payments for the average user, it's a lot easier for me as a user to do cross-border payments with Bitcoin, just anecdotally. And I also think that scalability, people aren't looking at it from a chronological or a long-term view of where you're scaling those transactions. So MasterCard, Visa are doing 60K transactions per second, but on the chargebacks, on the long-term view, it's $40 billion worth of chargebacks a year kind of thing. So that inefficiency isn't taken into account when you're talking about 60 transactions per second. Whereas when you're using a blockchain or a sort of more arguably democratically maintained network, you do that work up front. So I think changing the narrative a little bit around what scalability actually means and not looking at it from such an arbitrary transactions per second.
Usefulness.
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 Is how we talk about it at Kadena.
All right, Charles, do you agree with some of the musings about the Ethereum virtual machine?
So the Ethereum virtual machine was designed by a single person, and it was, like most things with Ethereum, a best attempt at an experiment. It's a stack-based VM, and there are better ways of doing it. Our company, working with runtime verification, did the first set of formal semantics for it, so we helped with the KEVM, and then later we built a better version of the virtual machine based on the LLVM, which originally came from Apple, and that was done by a team out of University of Illinois. There's nothing wrong with it. I mean, there's nothing wrong with WebAssembly or the JVM or the CLR.NET. These things are just all ecosystems or environments to run code within. And so it's a much more reasonable question to ask, what type of code do you want to run, and what are you doing with that code, and who are the customers of that code? And so you have questions of privacy. For example, do you want the whole world to see the computations you're doing? If you're talking about operations on people's salaries or medical data, probably not. You also talk about verification of the outputs. So Ethereum's kind of a dumb system, and it just says, all right, put 11 people in the room, and if 6 of them say the answer is 5, the answer is 5. Who cares? So you can actually do these things in a far more elegant and intelligent way. It's called verified computation. So what you do is you have some server off in the distance run the computation. You give them the input, the program, and they return an output with a proof of correctness. And there's actually a platform that Microsoft created to do this called Pinocchio, and that proof is constant size, and regardless of the input and regardless of how big the program is, and you can just verify the proof to actually know that the output is correct without having to redo the computation. So if you're going to keep the replicated model that Ethereum brought out, this whole gas model, I think the only way that that's going to be reasonable is a bootstrap 2 layer 2 protocols or a bootstrap 2 verification of compressed representations of the work. So in other words, let's say that you want to play poker. You don't want to run the game on the VM. What you want to do is use it as the entry and the exit point, have the game run in some other place, like an MPC circuit or with verified computation, and then when they come back, they give the proof, and that's what allows you to collect your winnings and losses. That game could have gone on for 7 hours, had hundreds of hands, gigabytes of metadata, lots of transactions, but you only have 3, the entry, the exit, and the proof. This is where we probably need to go, and there's a huge amount of research with a variety of projects. Some we do at Tokyo Tech and at Edinburgh, respectively, projects at MIT, for example, with the Enigma project, and Microsoft itself continues this research, as does IBM. I think that's the next generation. The other side of it is sharding the computation. So you say that instead of running one environment, we're going to run multiple VMs, and we're going to somehow batch contracts so that they trigger in different places and they don't conflict with each other. And there's been a variety of good projects that have done some good research there. The last point is correctness. One of the reasons why you build these environments and you write languages, and Kadena actually did a good job with Pact. It's, I think, a Lisp dialect. It allows you to do formal verification that the contract code matches the business intent. So basically, you say, here's a multi-sig contract, or here's like an ERC20 token. Here's the business logic behind how that should behave. You write the code, and then you can actually prove that the code is correct. The environment you run the code in, the languages you write those contracts in, it can either hinder or help you in that process. The problem with the EVM in Solidity was that it was all screwed up. The semantics were incomplete. You'd have to look to the EVM to understand Solidity. And it was very difficult actually verifying contracts were correct. It took years for people to get around to that. So we did the formal semantics of it, and later built Yella specifically to try to correct that. And we've also written domain-specific languages like Marlowe and Plutus, for example, to make that easier for people. And we see a lot of projects doing that. So it's a pretty complicated topic, and there's a lot of nuance to it.
I'm glad you mentioned the Pact. That was when I was looking up, what Kadena is doing. The Pact was really interesting to me. I can't code myself, but looking at it made a lot more sense the way it was written than looking at a normal group of code because I can't do it. So was that kind of part of the thought process behind that? You want to scale that up so that anybody can look at it?
Yeah, and I just want to say thanks, Charles. You kind of took the words out of my mouth of what I was intending to talk about today. But on the note of scaling out, we intentionally built Pact to be, our view is that smart contracts are more than just code, that business users should be able to, at worst, read what is going into potentially a binding contract with a ledger, and at best be able to read and write it. So Stuart Popejoy, one of our co-founders, wrote a language, a domain-specific language at JP Morgan that traders use every day, non-technical traders use every day in production to execute trades. We took that similar sort of approach in designing Pact, so it's super easy to learn. We think scaling out the smart contract layer should look like teaching someone Excel or SQL. So like your non-technical business marketer will learn SQL to interact with databases, the same way that your non-technical developer can code up smart contracts in Pact, and we've added, as Charles mentioned, formal verification native to different Pact properties, where you can actually check on the smart contracting layer that your smart contract isn't inducing an inflationary bug. So you put function conserved mass to ensure that there aren't tokens being created out of thin air. And that on the micro level kind of extends to writing out formally verifiable interfaces. So our version of the ERC20 effectively will say what this standard can do, but also what it can't do. So that way, an exchange, a decentralized exchange, can know every single time if they're going to accept a Kadena effective ERC20, that it will run as expected, and we won't. They won't have to be liable for injection or inflation attacks.
Yeah, just real briefly, another dimension to look at with smart contracts is the notion of information sources. So cryptocurrencies are kind of blind and deaf. They're getting smarter. They used to be dumb too, but Ethereum made them smarter, yay. But they live in their own world, but that world isn't so fun. It's pretty simple. And we live in the real world where the Broncos win the Super Bowl every now and then, and certain people get elected president over other candidates. So you have all kinds of conditional settlement, contingent settlement, contracts that are based upon events in the real world. If the Broncos win the Super Bowl, I win the bet. If this horse...
Oracles.
Yeah, oracles.
We need oracles, essentially.
Yeah, data feeds are oracles.
We don't know what's true. The smart contract doesn't know what's true or not true unless it has a verified third party telling it, which goes and adds a layer of something and possible error to it with going and relying on these third party oracles.
Right, and that has a huge impact on performance, because you could have a theoretical peak of some enormous capacity, but if you're waiting for a data feed to give you information, if that doesn't come, it could stall your entire system.
I listened to a fascinating interview with one of the founders of Augur, which is a prediction market, and they were talking about what happens if people go and do a fake news narrative on Augur and just keep saying that the truth is not the truth, and he just kept saying, oh, we'll just keep forking and forking and forking, so then you have a fork of a fork. So it is it's kind of separate from what we're talking about, but it's a real problem. The use case is smart contracts are code. Code is law if you're talking about 100% on-chain governance. But then when you're doing 100% on-chain governance, you have to have inputs. You have to have injections of truth into that. But that truth can go and be corrupted, and then you have different narratives of what the truth is. And that's an inherent problem that's created and that we're trying to all solve collectively.
So
just to tag on to that, so Pact actually has by default on contract governance. So every single contract you have to set up. It could be a single key holder, but it has native multi-sig for effectively every contract. So when there is a upgrade to one contract, downstream has to vote to move to that new upgrade.
Now, what does everybody here think about admin backdoors in terms of smart contracts? Do you think that breaks the whole immutability of the industry, or do you think that it's necessary for true scalability in governments when developing these?
Well, so this isn't a backdoor. This is you define it up front, and this is only gets called whenever there is a need to call it if it's interfacing or interacting, importing a different smart contract, then it gets called. It's not like a backdoor.
Okay.
Yeah.
It depends. I mean, if you have a gold-backed ERC20 token, I don't give a crap if your network's decentralized. The gold's got to live somewhere. So there's a centralized component. There's a centralized process there. So you should give people the freedom to build things in a way that allows them to centralize, federate, or decentralize based upon the business use case and how people intend on interfacing with that.
So Charles, in that case, would the ERC20 be an immutable bearer instrument, where if I went and stole that from somebody, I can claim the gold?
To be immutable? That's the thing. I mean, it's like the base protocol has to be. The rules behind that have to be. And we have to know that the fidelity of how we assume computations are going to be executed will be executed that way. But then I, as the person who deploys things on top of that, should have the freedom to decide how my logic works for my customers. That would be like Amazon EC2 saying to Netflix, sorry, you have to build your app this way. They say build it how you want it, and here are the rules of how our infrastructure is going to work. The point of cryptocurrencies is to say, once those rules are set, they're going to be predictable and known and won't change without a lot of ruckus behind them.
Yeah. So
Whereas
layer
in a centralized
one,
solution, they can.
layer one immutable, and then layer two enterprise, and it needs to be somewhat controlled and have what we call a backdoor.
Or it can be immutable as well. It's a case-by-case basis. It depends on the applications you use.
It's interesting seeing the stable coins are coming out with the law enforcement backdoors being baked in.
The DoD is investing into a lot of projects right now.
And that when the backdoor is in your money, that's not a good thing. But also as a Silicon Valley entrepreneur, built a lot of companies in the past, one thing I know for sure is that we're not going to get everything right on our first try. This building software is an iterative process. And so the approach we're taking at Origin is, yes, we have the ability to upgrade stuff for a time, but our plan is to sort of ratchet down our powers over time and get to that point where it can be immutable and we can close that back door. But if we were to stop, working on the project and didn't have the ability to upgrade stuff, we'd leave the project in a bad place.
But the reason why we're all here, it started with Bitcoin, essentially. And it doesn't matter what we think about what Bitcoin is today or where it's going. I think that's more or less irrelevant to the discussion. But why we're here today is because of the components of decentralization, where there's something, when Bitcoin came out, everybody said, I own Bitcoin. I'm a part of Bitcoin. I was talking with my friend Damien, who works on the Bitcoin code the other day, and he was saying that when code is suggested to be updated to Bitcoin, it's not just the guy with the good personality and the best idea. It's literally has to have like 95, 98% consensus that it's literally the logical thing. And then by that standards, it goes true decentralization where the community owns it. And it's not this guy's Bitcoin or this guy's Bitcoin or these semi-centralized, decentralized entities, but it literally belongs to everybody. And I think for really people to blockchain to move into this, it needs to become a government, literally a government that everybody owns, and there's people that come in and out of it, but there's really no incumbents. And I think that's really the key long-term focus of where we're moving.
Liquid democracy is definitely one of the really exciting pieces, I think, of scalability. And I know you're at IOHK, you were working on doing like a DAO as a service. Do you see that as another key point here to help these other protocols upgrade?
Well, I mean, we wrote a paper on using liquid democracies with treasuries, and we did analyze a lot of different treasury systems, like the Dash treasury system and PIVX and these other guys. And voting is tricky because you have this thing lingering called rational ignorance. Basically, what that means is that the value of knowing something is less than the time it takes to know it. So for example, I could spend a huge amount of time learning about the nuances of the American healthcare system, and at the end of the day, my vote is the same as the crazy homeless person on the side of the street that thinks the moon is made out of cheese. So I ask myself, is it really worth reading 30 books and watching hundreds of hours of YouTube lectures to become an expert on this topic when my voice is identical to the uninformed? No, if you're a rational actor. So the default choice is just to not get involved or not invest the time. So then when you talk about these cryptocurrencies, these are very nuanced systems with tons of trade-offs and a lot of philosophy, and it takes years to become sufficient to be able to have a really reasonable voice. And then you have to ask yourself, well, what incentives do I have to invest that much time? Now, I might own a lot of the cryptocurrency, but we've already run this experiment once before with the modern governance behind Fortune 500 companies where the shareholders vote on governance for these systems, they appoint a board, and historically you'd say, oh, well, they should act in the best interest of the company. And then hedge funds come in, they buy their way into the company, and they force the companies to make very nearsighted short-term decisions to temporarily boost the stock price, sacrificing the long-term future of the company. In fact, CEO Panera Bread, he wrote a lot of articles and even left the company and took it private specifically about this. Elon Musk also complains about this greatly. So governance is exceedingly hard, even when there are financial incentives to get governance correct. You also have to look at the sophistication and the ease of use of the voting systems themselves and your ability to distinguish between people in the system.
Right. Yeah, one of the biggest problems is how do you do a one vote per person type model?
And is it even wise to do a one vote per person model, or do you want to do it differently?
But better than 30 votes a person.
Yeah.
Yeah.
Well, but we have that already, and whether we like to admit it or not, some people are more equal than others. Like in the American election system, your vote in Wyoming counts a lot more for your vote in California just because of the electoral system. So we'd like to believe one vote per person, but these systems aren't set up that way. The other thing is, what does it mean to vote? You have different voting orderings, like you have things like linear preference ordering versus plurality. So linear preference would be, for example, everybody on this panel, you would say, who was the best speaker? You can either vote for, let's say, Charles or him or whatever, or you can just rank them and say, who's number 1 and who's number 2 and who's number 3 and who's number 4 and 5, and pick your top 5 and order them. That's called a Condorcet or a Borda count. Okay,
And
you can
who's
actually
top of
run
the list?
elections this way.
Whoever's top of the ballot, generally by percentage, will get more votes than the person down there, lower on the ballot.
Right.
Yeah, so that's why I'm a bit confused that you mentioned that governance and scalability are orthogonal concepts in your mind,
Yeah.
because I think there's actually like a huge correlation between the style of governance, the sort of localization of governance, and how that interacts with the ability to scale an application or scale a DAO. For instance, like with proxy voting, that's a very like old, not old, but like corporate governance is not a new concept, and just building that out to like 6,000, 7,000 shareholders, that we could achieve scalability on that localized level, and then like merge that onto the base layer chain. So I'm just wondering why you think they're orthogonal.
Well, I think my take on it is scalability is what we need to get mass adoption. We don't necessarily need governance to get mass adoption. We might be able to get millions of users using the blockchain.
But not if it
And we
doesn't
don't have
work. Like remember when CryptoKitties came out, like grandparents were talking about CryptoKitties, and then they're like, if they were able to get through all the barriers and the MetaMask to actually use CryptoKitties, then because Ethereum didn't work, they're like, well, this doesn't work.
If
And
you have-
so it lost the shot. It lost the shot, and now CryptoKitties is forgotten.
Well,
Yeah.
if you
I think
have
usability is a
scalability-
far more pressing issue for us to be addressing than scalability.
Well, scalability without governance is Postgres, right? It's just another database. So I don't understand why you can talk about them separately.
Well, you need a consensus mechanism,
But-
whether it's
They're separate because they try to achieve different ends. I mean, with blockchains, we set the rules and we go ahead and run the system. We say, this is how validation works. This is how the game of poker is played, and that's that. The question of governance is, how do we change these after we've set the system in motion? That's why it's different than scalability.
Now, let me ask a question to everybody here. Is when studying governance for respective projects, are you studying different governmental political systems in the world for nation states, cities, nations?
Oh, yeah.
Because literally, I think blockchain is a computer version of our government. So we literally need to be looking at it for the world. So, for example, the United States has 3 branches of government which supposedly have checks and balances, and sometimes hostile actors who hold all the tokens try to attack that. But then, does the governance hold is the good question.
Yeah, we operate in 16 countries, from Argentina to Japan. So one of the luxuries of that is that we kind of get historical insight into where things have failed. Like, we talk to our guys in Ukraine and Argentina about monetary policy, and they have some rich and exciting stories of where these things can go wrong. And it's kind of nice to have that diversity of thought. But yeah, we definitely do look at historical failures and current governance systems for inspiration, and there's a lot of meat there. And there's also throughout the whole 20th century.
Do you think democracy is the ideal system of government for blockchain, or benevolent dictatorship, or socialism? I mean, we could go and take different chains and different governance models and say, this is a benevolent dictatorship, this is a democracy, this is a mess.
Yeah, I was actually thinking about this the other day. So one of my degrees is in political science.
We were talking about that earlier. Yeah.
And the one true thing that political scientists agree on is that no two democracies have ever fought each other. So everything else is very probabilistic. So
I guess that's how you define democracy.
yeah. Well, no, that's not how I define democracy, but sure. And like one of the case studies that we would always turn to is Singapore. Authoritarianism worked on a scale that's small. If you tried to apply the same style of Singaporean authoritarianism to America, it wouldn't work.
But Singapore would call themselves a democracy.
I think we might be getting off track here.
Yeah, welcome to our panel on the governance around the world. Now, it sounds like we definitely have some consensus up here that the governance is something that's very both tricky to figure out and central to scalability. Although Josh, you were kind of, not against it, but you didn't want it to seem like it was the primary.
I still feel like there's separate issues that we need to address. Separately. I think for scalability, it's all about the trade-offs. Vitalik termed the phrase the scalability trilemma, which is you've got performance. Why are you laughing?
No, I just saw Charles chuckle.
We have performance scalability, you have decentralization, and you have security, and there's trade-offs you have to make between these different things. And it's very reasonable sometimes to trade some of your decentralization for faster performance. So there's reasonable trade-offs to be made, but I think it's important that you're honest about that and the compromises you're making. Not everything needs to exist forever. Not everything needs to be verified by 10,000 nodes. There's different trade-offs we can make, but I think it's important to understand what those trade-offs are and what you're getting yourself into.
All right, so we only have a few minutes left, so I wanted to do two things. One, since we kind of boiled this down to governance and else, I wanted to ask the audience by show of hands, do you believe that, after listening to us, do you believe that governance is one of the primary things for scalability? Some agree. And so for the rest of you, that would be something else. So if anyone had any questions to direct toward anyone up here, this would be a good time. I see.
I'm having a hard time here.
Why are we talking about scalability when the users is less than 50 million people?
Well, I think that what's going to happen is it's never going to get to more users when it's not scalable. The reality is, right now, blockchains are essentially a proof of concept and aren't effectively being used for anything other than speculation, gambling, and pseudo gambling. And the reason is because those things have direct financial gain. I do a transaction, maybe I make some money, but we don't have any practical public work chains where you can actually just do lots of transactions very fast and not pay anything for it. Ultimately, blockchains need to get to the point in deploying where they're lightning fast and free or nearly free, and until we go there won't be people using it.
I actually would take a little bit of a different approach to that. I think that Silicon Valley has kind of lost the plot on what we should be building blockchains for, trying to recreate existing applications as dApps. Like first principles, blockchains create it's mechanized trust, so we should be injecting it into building systems that suffer from counterparty risk. So going to regions that don't have hundreds of years of institutionalized trust baked into their everyday life. So in developing markets, and then building out counterparty, trading systems. So someone talked earlier about supply chain management and trade finance, like building more of those applications rather than, decentralized Uber. I would say maybe decentralized workflow sharing for larger enterprises, but I don't think we need a dApp to be, I don't think we need Uber on a dApp.
Well, I'll just stress that one. So decentralized Uber, it's interesting in countries where you can't use Uber because you don't have a bank account. You've got 2 billion unbanked people on this planet who are not welcome on their app, right? So it's very interesting for them. What about Uber in London or Vancouver, where Uber has been banned? Decentralization brings really interesting properties there. So I agree with you on starting with first principles. We shouldn't just try and jam stuff in there just because we want to, do X on blockchain. But you want to start with whatever unique things that you get from working with blockchain, and what does it give us that we wouldn't have otherwise?
So to get to the question that was asked, why are we talking about it? I'd like to believe because we started with the principles first, and what we're now asking is, can we achieve scale but maintain the principles? So it doesn't really matter how many users we have. This is a research question. It's an academic question. We have a configuration of how we'd like the world to work, and that's a collection of rules, and it doesn't have a leader, and it's decentralized, whatever this word salad means. And we'd like to say, as we go from 1,000 people to 10,000 people to 100,000 to 1 million to 10 million and so forth, can we keep that configuration, or does it change as we grow to these new levels? And how will it change? And how many of the principles can we keep as we grow? You will always make compromises along the way, and that's the point of this experiment. It's good to ask the question now before we get large-scale adoption, because when we do, if we get it wrong, all we've done is traded one dystopian centralized world for another dystopian centralized world with centralized control.
And there's been a lot of debate about this. Are we in the infrastructure phase? Do we need to build the infrastructure before the great apps can be built? Or do we need to build the great apps first, and then that will push the development of infrastructure? I'm more in that camp. I think we need to have real use cases.
Because you're a Silicon Valley guy.
We need users. You need growth.
Did you call it
okay,
a
Mr.
Silicon Valley guy?
He did. All right. So we're a little bit over time. That was. I'm sure we could go for another hour and a half.
Reem has a question over there.
Oh.
Go for it.
We got to take one more question.
Come on, he's got a great beard.
Our favorite.
He's got a question.
From the best person in the audience.
No, I have a question. Since all you guys work hands-on on these projects, for those of us that aren't coders, could you possibly explain how many of the challenges with scalability that you're facing have to do with just protocol design or actual technological tools?
Mostly it's protocol design, because we already have protocols that can scale to billions of users. It's called Google. The whole Googleplex is an aggregation of lots of software that serves your needs. And how many people use Netflix? But the problem is those are centralized, right? So how do you take the goodness there and move them to a world with the principles that we have? And so that's new protocol design.
Excellent question, sir. All right.
As if it was planted.
Like I said, that was a lot of fun. I don't want to hold us up any longer. So that was our scalability panel. Thanks for letting us talk your ear off for about 40 minutes.
Thank you.